our last presentation of today, and Nathaniel Palmer and L.Dugan will tell us about their latest achievements. Okay.
Thank you. Thank you, Jacob. And well, I'll go briefly on introductions, and I'll introduce Lloyd and let him just start speaking when appropriate. But Lloyd and I have worked together for 30 years and have been part of the decision community for almost that time, beginning with kind of how things have evolved, and Lloyd more visibly and aggressively, particularly on the standard side and on the modeling side. In my case, more so on the vision, the ideas, and the implementation, and being able to bring this into the transformation of programs and do what I can to expand both the adoption and innovation around it. When I say it, I mean, again, having a very deep personal interest and involvement in specifically decision intelligence, decision modeling, and how that world has evolved. We, unlike past years, actually took the time to write a white paper, which is available on the DecisionCAMP site along with our slides. I would love feedback on this. This is in some ways, controversial idea. It's becoming less controversial as several things are catching up with what we started exploring and pushing over about an 18-month window now. But it's still the case that there's, in many ways, a holy war going on between traditional model-based and model-driven approaches and what's happening with the advent of how Gen AI has evolved and the more mature capabilities aligning with it in the NLP space and what that means. And what to us it doesn't mean is that it obviates or completely offsets the history and current state of decision intelligence. But it also doesn't mean that the world isn't changing, and that in that evolution, we see a direction and an emergent architecture that brings together traditional capabilities that we would otherwise look to from decision modeling and applying that, leveraging graph-based technology and specifically GraphRAG. So we would love your feedback on the white paper as well as on the presentation, and welcome questions as we go along. We actually have the fewest slides that I've ever put together for this event or similar events, in the hope that we would be able to inspire some conversation. But I've added a couple of slides from what is on the downloadable presentation, and Jacob, I'll provide this to you. But this is from both a case study and kind of evolving deck that I've presented over the last, certainly last 5 to 6 years, but specifically slides that came from a conversation earlier this week, talking to a government agency, and specifically talking about the notion of how do you get deterministic responses and answers in a highly regulated environment. And so part of that presentation was talking about the case study that those that know me often associate with me, and probably with Lloyd as well, which is the transformation of a very large government program in the U.S. that focuses on the adjudication of access to healthcare. And it's one where, when I joined and quickly brought Lloyd over, but I joined with the charter of transforming that program from the role of the chief architect. It was a largely manual, despite the fact that there was a significant investment in automation technology. There was very mature state-of-the-art BPM in place. There was what we now call IDP in place, multi-million-dollar investments in exactly the right software you would need. But nonetheless, the work was very manual. Everything was seen as an exception. The discussion was always that there's no way that we can automate this. And the lack of automation was the greatest challenge to the program, because it meant that the transaction costs were far greater than they needed to be, that there was far more cost and resources going to not the benefit, but the adjudication of the benefit. And my goal was to drive everything down to, trending down to zero as much as possible, to be able to have all of the costs be focused on the benefit, not on the adjudication and the transaction costs that go in that are not adding any value to it. And that the only way that we'd be able to do that would be through the leverage of automation. And you would say, well, why don't you just fix these broken processes? And well, one, maybe you haven't worked in the government before, but the challenge is not just that the processes are inefficient or dysfunctional in some cases, but they have to be what they are. There is a regulatory and statutory and policy set of burdens and requirements for things to be done in a particular way. So the only way that I saw to leverage the benefit of automation, but do it in the way where the gold standard and what was the requirement is that all work would be performed by human beings, is to create a digital workforce that behaved just as the human workers, and would be able to, and actually in many scenarios would be able to have them working 24/7. In this case, they actually work in the same shifts. That's another statutory requirement, that they're working in the same window as human workers. And rather than taking piece parts to automate instead, which would present us with that fundamental issue of the work is too complex, there's too many exceptions, there's no way that we can automate it. That's true for 90% of this particular work category, work type, or task area, but 10% of it can be done. Or in another case, 90% of it can be automated, but 10% of it's still gonna have to be manual. But you couldn't know in advance which you could automate and which you couldn't. You could only do it in a very contextualized, situational way based on the analysis of that actual work moment in that particular work stream, which again meant that the only way we could do this was to build a digital workforce. So today we call this agentic AI. At the time, that wasn't a term of art. Even agent, although in the computer science realm, it was well understood. Not well understood in the business realm and in the contemporary technology space. We created digital workforces that log in, perform, do the same work as human beings, and we're able to deliver with that enormous gains in efficiency and value and transparency, the predictability of that work. And we did that using a lot of the technology that was already in place. We added to it new capabilities, which included at an early stage, and it was an absolute requirement that we started to take advantage of specialized AI that provided natural language processing and things that allowed us to get an understanding of the work in a way that could be machine understood, whereas a human being could read, infer, and make their own conclusions. We couldn't have the elements of automation doing that, and we not only would that be just a bad idea, it would be an illegal idea, because they would be making their own decisions as opposed to following and applying rules of policy. So the most critical part of this transformation, what made this possible, was decision modeling and decision automation. And when we started down this path, and this is what's still in place today, when we started down this path, DMN didn't exist. There were some emergent standards. BPMN existed, and that was certainly part of what we were doing. But the only, well, I don't mean to say this as an endorsement, because I am particularly biased, but I would say at the time, the only practical approach was the decision model. So we adopted the decision model. If you're familiar with it, you'll recognize the models there. But what made this automation possible was this transformation, going from having all of the work being very prescriptive but so verbose in how it was defined and constantly evolving, because this was a new program, relatively. We did this at about year 4, and we already had a lot of paved cow paths and legacy to deal with, but you also had a continuously evolving regulatory environment and literally hundreds of thousands of pages of standard operating procedures, rules, these matters which needed to be followed and applied, such, both through performing quality control analysis. So a common scenario where 5% of the work was manually examined and re-reviewed, and the only standard is, were the rules followed, not the codified business rules at the time, because those were very limited. But the policies, the SOPs, the work instructions, is that what was followed? Not was the right outcome achieved? Did we do right by the consumer in this case? No, it was. And that is how the majority of government work is measured and evaluated. It's simply, did you follow the rules? And upon appeal, would you show that under the same circumstances, the same thing would happen over again? And the only way that we could do that in the context of a digitized, automated scenario is through the development of business models, decision models, rather. And in doing that, we have all of the benefits that we didn't have before in terms of the observability, the being able to prove that we were following not only the right policy, but what was in effect at that time, which might be entirely different of what's in effect at the time that it's appealed or the time that it's examined through some other means. And so we now had a far greater basis for governance and observability, reportability, and the ability to continuously optimize that. So I say all of this as the intro to say that I'm somebody that's already very much bought into the value, the power of decision modeling and decision intelligence, that it's an absolute imperative. What does it mean going forward, and what is our proposition here? And it's that the methodology for understanding how we structure this it doesn't change a whole lot. The instantiation of it and where it goes is something that is necessarily evolving. And it is the role and the introduction of large language models as both frontier models and foundation models and models that are providing probabilistic answers, that they are offering significant advantage, but also introducing the significant challenge, particularly in the regulated world, that we cannot have automated outcomes where it's probably right. It's not that it's violative when whatever percentage of them is wrong. It's that we need to, in a regulated environment, we need to be able to demonstrate that under the same circumstances, a million times over, the same outcome would be achieved. And we can't demonstrate that with probabilistic systems without wrapping it and bounding it by a deterministic framework. And that is what we're suggesting, that today, were we to approach the case study that is describing, or the one that I was speaking to earlier this week to the agency or to others in regulated environments where we want to gain the value of scale that we get from AI and in particular agentic AI, where we're combining AI and automation. The only way that we can make that work today is bounding it with the level of determinism that we get from decision models, and the way that we would do that today is using GraphRAG. We've, with that, come up with a notional 7-layer framework that we describe in the white paper, of the pieces that go into that, and a critical part of that is still the actual decision service and the logic that frame it. So it this again does not obviate the role of DMN or TDM or decision traditional decision models. The other notion of introducing a graph structure to this is by being able to, particularly in a regulated environment where we need to be able to show not just chaining, but fairly widespread linkage between policy and how a discrete rule changes depending on the context based on policy, current or future, and leveraging graph structures to do that, and then being able to enforce that and instantiate that with GraphRAG. So, Lloyd, are you on and ready to speak?
Yes, I am. Can you all hear me?
Okay. I can, so I presume everyone else can. So, Lloyd, with that, I'm going to let you speak to the models, and so I'm just going to advance and let me know what you want.
Go back.
Okay.
Previously,
okay.
And then I'll ask you to advance.
Yeah.
Right.
Please.
So thank you, Nathaniel. So the two things in highlight, we've got specific slides for to sort of illustrate it. Don't have slides for all 7, but you can kind of get the gist of it. It's the second and fifth layers that I think from our standpoint are the ones that matter most in terms of the framing and how to ensure that at the end of the day, the decision is something that we can all find acceptable. So go ahead and advance. Yeah. All right. So you've got with knowledge graphs as a way of representing knowledge, has a long and rich tradition going back several years, and in some sense might even be said to predate AI itself. But AI also goes back much further than people's memories probably realize. It is, it belongs to a family of graph relationships, whether you want to call them taxonomies or ontologies or any relationships, whatever. You've got this way of breaking a large complex set of things into smaller chunks that can then be navigated to support queries, to gain to get information returned, to make evaluations, and depending upon how sophisticated you want it, to reflect some level of intelligence, if you will, maybe even wisdom back at you. Granted, it's all limited depending upon what's in there and how you go about getting it out. But the point is that these approaches give you a way of framing how to do that. So I found this really nifty graphic. I've been using it a lot over the last year or change to express sort of why knowledge graphs should matter in this context, because it brings into additional concepts, vectorization, and as well as the use of tokens. But I'm going to start on the right and just kind of walk through what should be clear after you look at it a while and think about it for a bit, is that the accuracy or the utility, if you will, of the return results gets better as the ask gets more specific, and the information structure of the vectorized knowledge information is more granular. You're going to get better and better results, right? So if we start with the basic question of I want to see all journal articles about mouth neoplasms written in 2023, right? So the stuff in the blue goes in the stuff on the right, goes with the stuff in the blue on the left. The stuff in the yellow on the right goes with the stuff in the yellow on the left. So just to be clear, that is the color coding going on here. So you can do a semantic search on journal articles. You can date restrict them by year 2023. You can do topic searches for mouth neoplasms. So this is a very basic kind of ask of this information, and you'll get a very basic set of answers back. Not unlike the old Google search, you just type something in and see what you get back. You're going to get a lot of noise back probably, but the signal will be there somewhere, and you can use it. If you move to the next one, So it says, I want to see all journal articles. No, not the next slide.
I'm sorry. I thought that was my instruction. Go ahead.
Sorry. I want to see all journal articles similar to Article X that are tagged with cancer of mouth or any synonym or narrower concept that user Y has access to. It's already sounding like a mouthful, but as it says in the thread in the middle, this is kind of a personalized recommendation. So it's kind of understanding what on an algorithmic basis what I want to see, and it will return that as to me based upon the specificity I give to the ask, or in this case, you can call it a prompt if you want, right? So that will be better served if there's not just a basic sort of extracted entity list to work with. There's something else going on that has personalized the relationships in a way that if I ask the question a certain way, I'll get the kind of answer I'm seeking. Which is why this is beginning to get away from just the straightforward knowledge graphing into something a bit more detailed and somewhat richer. Then you go to the third thing at the bottom. It says summarize therapies for mouth neoplasms using only articles tagged with mouth neoplasms or any other synonym or narrower concept. Well, that's actually quite an ask. You're asking for the summary, which is a series of evaluations collected together, and you're asking for a topic that really has some adjacent topics with it that could also be included in the return. Not as noise, but as signal. So at this point, we really do have to look at something like the retrieval augmented generation using the graph structure of all this, or GraphRAG as we've been calling it, and everybody should be understanding it. Now, how is this supported on the left, right? Well, you've got the knowledge graph, which is just the nodes and edges of the knowledge bits as they've been encoded, as they have been modeled. And the vector database, where all of this information is vectorized into numeric information that is subject to quantitative analysis. This is how you get proximate measures of topicality in a way that you really couldn't do through a sort of literal comparison of word strings. You reduce the word strings to numbers, compare where the numbers are, and you get what you want. So again, it's the combination of the knowledge graph, which facilitates the traversal of this information, with the vector database, which informs that traversal, as well as just sort of generally querying of stuff, that brings this up to a level that the kind of asking to the right can get to a meaningful result. So knowledge is chunkified and vectorized, and the graph is created. And this now supports a richer retrieval based upon the vector search that you can do with the traversal assist from the knowledge graph. So GraphRAG then provides all the probabilistic answers, and these will improve over time in learning of the underlying model. But the models can return better and better results the more structure and context we give them. But they're still never going to be really authoritative, at least not for a while, right? Because we don't have that trust. That was an issue raised in a previous session, that there has to be a level of acceptance that that's going to be okay. We're just not there yet. Maybe never will, but we're certainly not there now. But it doesn't mean that there isn't progress. It's more of like an asymptotic convergence on something. It never quite gets there, but it always gets a little bit better, although the incremental improvements begin to look pretty small after a time. So go ahead and advance. All right, so this is a very basic DMN decision service model representation of the fraud example. And in the CMS program that Nathaniel and I both are heavily involved in, me as in his old job and he in his new job, is a big topic is fraud. And so when in the eligibility space for gaining access to the federal market exchange for healthcare plans, because that's what we do under the auspices of the Affordable Care Act, we are evaluating someone's eligibility to go to a site to be able to download a plan. So it's not claims processing. So the kind of typical fraud payout problems that associate with most government services on the CMS side really is not in our wheelhouse. But the commonality is that we're still looking at documents that establish certain qualifying information. We need to certify, or rather verify, that these documents are good and can be used to resolve issues that have been reported about someone's application. And that means looking at the document, but it also looks at the registration behavior of the consumer. So there is, because there's all sorts of aggregators out there that can pull together different, a group of people and sort of mass register them. That is part of the law. But the policies around that are shifting now because we realize that it's now a threat vector for fraud. So this is not to give you the detail of the fraud model or the calculations they're in, but just to say we would be able to have data that we have accumulated, document level data that we gather either through visual inspection or algorithmic evaluation of document images, both of which we are pursuing. But you can also look at consumer information. You can also look at consumer information over time to be able to create essentially what might be called a watch list for people who are registered or whose registration patterns over the years or in any particular plan year cycle have very suspicious markers, right? So the fraud model then picks up this and holds it as part of the decision-making information. And all of that feeds into the decision service that determines the fraud, scores the fraud, if you will. And if the score is above a certain amount, then we take action. We consider the documents unusable and we take further action with the consumer applicant if necessary. This is available to us through the DMN representation, through the business knowledge model concept, which allows for an API call to feed into a decision. And then the service is just the technical wrapper built around the decision itself. So we can look at whether the decision evoked here is before a human in the loop review moment, which is not what we're doing, or after, which is what we are doing. So we're funneling all of stuff that needs to have a HITL review to have the HITL review. So in our decision service, for example, we would look for confirmed true positives, confirmed false positives to separate out the wheat from the chaff. GraphRAG will hold the accumulated patterns of the document markers that we find, the simulation or the signatures of fraudulent documents. And we're looking at we have third-party services in mind to perform those algorithmic checks, and then we decide what we do with the return results of those checks. But the GraphRAG stack can also hold the signatures for the fraudulent consumer behaviors. That's also configured to this. So the fraud model then evaluates all of this and returns information to be used in the matching of what we get in the scoring with what's determined through the API call, and out of that we will get the decision. So again, GraphRAG provides all the probabilistic signals, but the decision service enforces the deterministic policy-based outcomes of all of the data that's being used. This is a construct that is directly auditable and traceable in a way that is hard to see if you just leave it to the token back and forth exchange with the AI models. So we see this as the best of both worlds. And I believe it was a presentation of earlier in the week. I apologize, I can't remember who did it, but it was a very nifty graphic that showed that the complementary weaknesses, I think was the term, between a decision-oriented approach and an AI-oriented approach. These are nicely offset when used in this design pattern. So back to you, Nathaniel.
Okay, well, there we go. Probably would have served us well to advance to that, because you provided the talk track to this, and I don't want to be redundant about it, but there is an implicit pipeline that Lloyd was describing very well, and it's not just for discrete rule validation. So one of the distinctions here in our suggested implementation of this and where we're going and exploring on our own is how we're applying the same deterministic logic where we don't know to ask the question at the moment that we begin that work, and that we're able to go across a broader spectrum. So that's, we're leveraging the knowledge graph concept and then distilling that so that we have discrete and anticipated outcomes, but not having the ability to define in advance all of the criteria and rule checks that we'll be applying. So where we see this, and certainly we talked about the case study that we've used as a test bed for a lot of the work that we've been doing and advancing, but expanding beyond that. So in cases where there is, in particular, a lot of tacit knowledge, where there's broad regulatory requirements that have a very fine-grained applicability, but again, where we can't determine it in advance exactly what we're looking for. We're not going with a binary question to satisfy. That we're looking for things that where there's a substantial amount of noise in the signal to noise scenario, and that we need to be able to use the approach and the way that we have analyzed policy and refine rules from that to be able to prioritize where we further look, and then ultimately are applying more discrete deterministic rules on determining outcomes and what applies. It is much more of a architectural approach in that regards than it is a specific system. We could generate some sample code for things that we're doing, but the concepts behind the white paper is not going to be in GitHub. It's something where it is a multi-layered approach, but it's one that is both evolving with the direction of the current state of both generative AI and as well as natural language processing, but also being a expansion of how we're applying deterministic rules and the way that we look at decision modeling and then ultimately how we instantiate that. So again, we'd love to entertain questions now, and we'd really love to have feedback on the white paper. But otherwise, we're closed out on our part, and I guess we're closed out for the event. So Jake, I guess back to you.
Okay. Yeah. Thank you. And let's see if we have questions. Anybody? I guess from your presentation is that you offering architectural approach right now. It's quite interesting, and I would not say easy, but I assume it's just approach, but you don't have it in real checked on real customers. It's not in production yet, and that's why you want to get responses, right?
Well, yes and no. So let me decompose those things. In terms of it being in production, absolutely, we have it in production today. But again, this is something that's highly evolutionary in that we'll never have it done or the complete solution as we envision the potential. So it is discrete parts, but the idea, are we using GraphRAG today in production? Absolutely. And we're going down the journey of converting a lot of what we have in formats outside of this, not just decision models. And it's not that we would be replacing decision models per se with this, but we have structured knowledge that's not in a true knowledge graph, that's in a different type of knowledge-based structure, and for which there isn't any inference from that it can be read and learned by a model, but that's not, we're talking about a very different and more structured approach. So that is the transformation of that we're doing today, of which what is in production. That's going to be a multi-month journey. Whoops, and ultimately, it'll be for me at least. I suspect our project will outlive Lloyd's full employment. Lloyd will retire before we're truly done with this.
That's a certainty, yes.
But if just if you mentioned, for example, claim processing, if you can take one particular line of business like medical claims, and I can see that you cooperate with TriceTech and they're very good in this area, and so if you can expand your architecture with this one particular example, it could be easy for people to follow what you're actually offering. And I also I just put a link on chat. It's a decision management community, was recently redesigned, and it's much easier to contribute over there. So we have articles, and if you want to publish this article, and we can create news, and we can ask all members of community to look at your article, and maybe you can get your customer this way.
Yeah. Well, we'll do that. We very much appreciate that. So we'll absolutely do that. And it's
so
again,
it's actually there is a question over there from James. So he wants to see your white paper. So if you can do it on DM community, everybody will see it.
Yes.
James, you want to ask question?
Yeah.
Yes, I do have a question relating to RAG overall, but GraphRAG, I think it's applicable as well. So one of the main areas, so there's some debate out there that RAG is dead, and so on and so forth. But in essence, when it comes to determinism, certainly an LLM is a read-only kind of system from the perspective of there's a stop date to its training.
Right.
So, but the main argument being made is when it comes to the code generation, that you don't need these kind of vector embeddings to sift through, sources of code and eventually generate code, particularly in popular languages where there's a sizable data set available, in the public domain. But when it comes to the government sector and the public sector, I know one of the standards is CMMC and so forth. Do you see a situation where you still need to create the kind of checks and balances in the life cycle of the implementation of these intelligent automations that are policy or rule driven, or do you see a period of time where I know one of the main news these days is that GPT, the version called Astra, which I think is the next version, has solved 10 of the most long-standing math proof problems out there with lien certificates issued for them. So will the kind of machine learning AI being developed ultimately achieve, in your opinion, the kind of determinacy where where it would eliminate the need for for rules and GraphRAGs altogether?
Someday, maybe maybe when we're in the quantum AI realm. But in for the foreseeable future, and in terms of what is going to be within reach of government agencies, and as well as most private enterprise, there is still the need, and we're starting to see recognition of the requirement. There was the kind of overdone notion of ethical AI, which was framed and focused entirely on training and training data as opposed to the outcome. And the issue was, whether or not there's bias in the model, and being able to demonstrate the absence of that, which isn't impossible proving a negative. But the much simpler test is being able to connect the outcome to the policy behind it, and demonstrate that under the same circumstances, the same outcome would be achieved every single time. That should be the standard, not perfecting the model from the standpoint of its training or the training data, which keeps it opaque if we don't have the standard and the yardstick being that we're measuring outcome against policy. And we've seen in the government space some early cases where that clearly wasn't happening, because they were using probabilistic models for claims processing and pre-authorization and matters of that sort. There was some, in one particular case, a lawsuit that came forward that showed that under the same circumstances, different patients were receiving different benefits, which is the gold standard that should be upheld in every aspect of the delivery of benefits. Is that the same circumstances, same benefits, same eligibilities, same outcome.
And I do have a follow-up for Lloyd in this case. I mean, having been, part of the authors in the notational space, and being a recognized authority in there, do you see any increased usage given the complexity of mixed environments of human and AI agents within particular workflows or policy implementations? Do you see that? I know there was a period of time where low coding, no coding environments were trending, but do you see these notations being utilized in those scenarios as well, or is people just moved away and just using a chat interface and expect they'll be able to manage these complex interactions?
Well, it's an interesting and timely question, because and I can speak a little bit from two organizations that I'm involved with that I think may help answer that question. One is the OMG, the Business Model Integration Task Force, the main task force, is gearing up to talk about whether or not if there are changes that are needed in the BPMN, or really the BPM plus space, which is BPMN, CMMN, and DMN, to reflect the use of AI. And so far, the general consensus that I'm pulling together is that aside from some additional annotations and maybe a few extensions, there's not really reason to rewrite the notation, because the semantic rules are good enough for describing the operational behavior of using AI. Again, the annotations and the extensions will help emphasize that. So there is work to be done there. It's not clear how far it will go, especially since no one really wants to reopen these task force. If you've ever been on one, it's like you're signing your soul away for a period of time, and you're not going to give it away so quickly once it's returned. The other is the Business Architecture Guild, which is conducting a similar or maybe adjacent effort with respect with how business architecture concepts can be modeled in a way that reflects the use of AI. We're just at the beginnings of that, so I don't know if there's much to say about that. But where this matters is there's another OMG standard that's related to what the Guild proposes under their BizBoc guidance document known as BACM, which is Business Architecture Core Meta Model. So from the modeler standpoint, I think we'll have our answers within a year, maybe two, but it won't be any kind of, I can't imagine it being an earth-shattering answer of any kind. It will help those who are trying to model it. Whether that becomes the key to some kind of graphical design language, which some thought BPMN might be, that remains to be seen. I hope that was a good enough answer.
Yeah, thank you very much.
Okay, thank you very much for your presentation. And this is was last presentation of today. And I hope to see all of you tomorrow morning for our last day. Okay.